All right, 3.3, circular function. So this is dealing with our unit circle. Once again, in our section, dealing with this. So here are your six trig functions and how they relate to the x and y values of your unit circle. Sine t is equal to y, cosine t is equal to x, tangent t is equal to y over x, cotangent t is equal to x over y, secant t is equal to 1 over x, cosecant t is equal to 1 over y. Keep in mind, some of these won't exist for certain values. Any of the ones that have a denominator of any, so anytime x is 0 won't exist, y is 0 for cotangent won't exist. Anytime x is equal to 0 for secant t won't exist. Anytime y is equal to 0 for cosecant t won't exist. Time for example. Find the six trig functions for 7 pi over 6. That's a 7. I know that's an ugly 7, but yeah, get the picture. 7, much better. So, sine of 7 pi over 6. On unit circle, that's the y value. So we look at the y value, it would be negative 1/2. Cosine 7 pi over 6 is equal to root 3 over 2. Negative root 3 over 2, rather. Tan, remember tan is y over x, so it will be negative 1/2 over negative root 3 over 2. We need to simplify these, can't just leave them like this. So we are going to eliminate the 2's right away, and negative over negative becomes positive, we like that. And then I am going to rationalize the denominator, so we're going to get root 3 over 3. When I say rationalize the denominator, I mean we have a root 3 on the denominator. If we multiply the top and the bottom by root 3, we get root 3 over 3. Next, let's do cotangent. Cotangent will be negative root 3 over 2 divided by negative 1/2. 2's cancel, negatives become positive, you're going to get root 3. Comes out nice. Secant t. That secant is the reciprocal of cosine, so it's just going to be, we know cosine is negative root 3 over 2, so it'll be negative 2 over root 3. Rationalize, please. And that's going to be negative 2 root 3 over 3. And cosecant t, that's going to be the reciprocal of sine. Flip negative 1/2, it's going to be negative 2. And there we did. We did 6 trig functions for 7 pi over 6. All right, so find all the values of t between 0 and 2 pi for which sine t is equal to 1/2. So look at your unit circle. Where would sine be equal to 1/2? That y value, well, clearly it's going to be in the first and second quadrant because that's the only place where y is positive. And you're going to see it's 1/2 at pi over 6. And you're also going to see it's that at 5 pi over 6. So those are two values that sine t is equal to 1/2. T equal to pi over 6 and 5 pi over 6. Find tan t if t corresponds to this point. So we know tan is y over x, right? So tan t is simply going to be 0.3350 divided by negative 0.9422. And if you divide those two values, you will get negative 0.3555, or around to that. Or around this, that should be 6, the next number if I'm rounding. If they ask you for what t is equal to, you inverse tan on both sides and go from there. Okay, as far as domain and range goes, here's the domain range of the 6 trig functions. If you look at sine and cosine, those are probably the easiest. You can put anything you want into sine and cosine and it will work. And the range will be between negative 1 and 1. Think about it. It's your unit circle. You're 1 unit of weight all the time, so it can never be bigger than 1 or less than negative 1. It can also equal 1 and negative 1, as you notice. The exceptions with tan, cotangent, secant, and cosecant. Remember what I said earlier in the video about how there are values that make 0 the denominator, right? Or denominator 0, if I'm speaking correctly. That's when, in certain cases, that's whenever the x value is 0 or the y value is 0. In the case of tangent and secant, this is when the y value is 0. Now, I should add in that for t equal to pi over 2 plus k pi, this is considering if k is an integer, right? So every time k is equal to 1, 2, 3, 4, 5, whatever that integer is, your tan value will be undefined, okay? And you can't put that value in because it's not part of our domain. Like 0 for k, at t equal to pi over 2, that's going to make your denominator 0, right? Because your cosine, your x value is 0 at pi over 2. And every pi after that, it's going to be 0. Same thing with cotangent and cosecant. It's going to be all except for those values that make y equal to 0, which is why it's just t equal to k pi, right? So every pi value, your y value is 0. If we look at the domain range, tan and cotangent, it can keep increasing forever, right? Because those fractions of y over x or x over y could get really, 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 really big and really, really, really small. So it'll keep going on from negative infinity to infinity. Same thing with secant and cosecant. Secant and cosecant, remember they're the reciprocal of sine and cosine, right? So if they're reciprocal, it's going to be, and the range for sine and cosine was negative 1 to 1, it's going to be everything but what's in between those, because those other values will not work. You're not going to be able to get 0.5 as an outcome, or anything that's between negative 1 and 1. All right, so playing a little game here. Is there a value for z possible for these given scenarios? So we have sine z equal to 2. Can sine z ever equal 2? No. Why? Because as you saw on the last page, your sine values outputs are going to be between negative 1 and 1. So no, it won't work. How about tan 3 pi over 2 equal to z? Is there a value that's going to make that work? No, because 3 pi over 2 makes tan undefined, because cosine 3 pi over 2 is 0. So therefore, your denominator will be 0, undefined, so no. Cosecant z is equal to 300. Can this work? Yes, it sounds ridiculous for a trig function to work for this, but remember, your range for your cosecant values, it's from negative infinity to negative 1, and 1 to infinity. 300 works for that. That falls under the negative 1 to infinity category, right? So you're good with that one, all right? Thanks for watching and playing along, and we'll see you in class.